Hi everyone, welcome to the last segment of the video. Now in this video, we are going to revisit the scalability of the marketing investment and also the optimal investment theory. Now in the last video, we have discussed that while there are decreasing investment, we can see that as long as they are higher than the hurdle rate, then we accept or we increase our investment up till where the rate or the incremental ROMI is less than the hurdle rate. Like for example, when we see the incremental from B to C, it is actually only 5%, so we should stop. So in this case, we should scale up to level B. Having said that, one concern is that you can see that they are declining incremental ROMI from 45 to 25. Hence, you might think about, well, is actually investment B or investment level B is worth it? So because of that, we really want to see the optimal investment. So in this case, we want to talk about the optimal investment theory. Now, as you probably be wondering, the return on investment is actually on a diminishing rate. Now, what do you mean by the diminishing rate? Diminishing rate is something like this, where you can see that an incremental investment, say from investment 1 to investment 2, it does increase, but it's up to the decreasing part. Okay, so I would say that it does increase, but the increase is not as much. So this is what we call diminishing or increase at decreasing rate. So I repeat, it's increasing at a decreasing rate. So if you think about like growth rate, so it doesn't grow as much. So it's like sort of like reaching the peak, or some people call it like saturated. So this is what diminishing rate is all about. Now, why this is happening? So let me give you an example. So say that if you are going to invest on certain kind of advertisement, like billboard, for example. Well, maybe at first it is actually very useful because you are new to the market, people doesn't know about your product, and with the advertisement, it really helped them to understand more about the product. Some people are keen to understand more, they may search online and so on. But as you pour more and more money in, at the same time your target population will already know what you are doing. Hence, the increase in your advertising budget might not be actually a good investment in a way, because now almost all people already know about your advertisement and all people know about your product. Then the growth rate is becoming much less and less, because basically people already know what you're doing, and therefore you will get this what we call the diminishing rate. So in other words, that the incremental ROMI is associated with each and additional dollar invest. Now for an investment level, so say that it is a $1 million, the incremental ROMI is given by the slope of the tangent. Now you might be wondering, what is tangent? Now we're going to look at the graph in the next slide. There you go. Now, right, and the slope of the green line is what we call the ROMI. The slope of the tangent to the curve at I is what we call the incremental ROMI. So this is actually the incremental ROMI. So this is the tangent of the line, and the tangent of the line is what we call the incremental ROMI. Now, we can see that this is, let's say this is a straight line, and this part is basically our ROMI. And at this part, all right, I'm just taking off the gradient. So this part is what we call the incremental ROMI. All right, I'm just going to put I ROMI. And what this is trying to say is that given that this investment level, and given that this is your return, this is what is going to be your IROMI, and this is what is going to be your ROMI. And as we talked about it, your IROMI is getting what we call the diminishing rate of return. Now let me just go through that one more time. So let's say you have that and that. So this is going to be your return, and this is going to be your marketing investment. And there you go, you got your graph right there. And so what this is actually trying to say is that, let me just use different color. So say that if my IROMI, which is something along, so this is the tangent of the line, and let's say that that's the angle that we are looking at. So let's say this is IROMI. Okay, so the idea is that when your IROMI, it's still higher than your hurdle rate. So if you remember, hurdle rate is our target rate, then we should invest more. So let's say you have the second one like this, all right? And you got the IROMI. So let's say this, call it number 1 and IROMI 1. Let's say this is IROMI 2. And if your IROMI 2 is equals to your hurdle rate, then you stop. Okay. So the idea is that your IROMI has to be equals to your hurdle rate. That sort of give you like sort of the optimum numbers. So this will give you your optimal investment. I'm just going to call it I star. And that will give you your optimal return. So this is what IROMI is used for, is to find out the optimum investment through IROMI and also your associated hurdle rate. Now in this case, what we can see is that at optimal investment, as we talked about just now, the incremental ROMI will be equals to your hurdle rate. That's what something that we want to know. And this is the very important point, as we can see from here. If ROMI increases linearly with investment I, then we also have this particular equation, whereby ROMI is equals to A plus B I. Now this is basically the same as your Y equals to B plus MX, if you remember from your high school. That's pretty much the same as what it is like here. If you don't understand what is Y MX plus B, don't bother about that. We will go through this as we go along to the next few slides. Now, then you will have this optimal investment and ROMI and return, which can be calculated through the equation right here, which we are going to touch on it in the next few slides. Now, I just want to give you a bit of indication. H stands for hurdle rate, and A is your y-intercept, and B is your gradient. Right, we're going to look at this a little bit in depth further. So what we can see from here is that this is showing you at optimum point. Now at optimum point, your IROMI, okay, I'm just going to show you here, your IROMI will be equals to your H. So this will give you an optimum investment. Now this will give you your return, and this will give you your optimal investment. And lastly, you can calculate the slope of the line to find out what is your ROMI. So this is ROMI and this is IROMI. So let's take a look at this example that we have touched on in the previous video. So you can see that there are different relationship between rho me and I, and you can see that intercept A and slope B can be obtained from regression. How? Alright, so as we can see that in here, we are plotting the relationship between rho me and I, which is investment. And if you look at our data, we actually have that. How? It's from here. You got marketing investment, you got rho me, marketing investment, rho me, marketing investment, and rho me. So if you take a look at this, you actually have 3 points for you to plot. So these 3 points can be plotted right here, here, and here. So this will give you point A. I'm just gonna take note of that. So this is point A, this is point B, and this is point C. And from here, you can generate your intercept level, which is 55%, and your slope, which is minus 0.2 divided by 1 million. Now, some people might ask me, how do we actually generate the slope and intercept? Now, you don't need to know this, but I'm just going to show you how are you going to able to generate your slope. So your slope, which is B, I'm just going to write that B, is equals to, right? You can pick or you can pinpoint any of the 2 points, okay? You can pick up A and B, you can pick up A and C, you can pick up B and C, it's up to you. But the formula is that y2 minus y1 divided by x2 minus x1. So as I said just now, you can pick any of the 2 points that you want. So let's say I'm going to pick this point, let's say A, due to convenience, percent, and 1035%. So because of that, you can actually calculate your slope, which is, I'm just going to take the first one as 2 and B as 1. It's up to you. But 45% minus 35% divided by 500k, right? It's 500k because of this is actually in 1000 minus 1 million, and that is going to give you this answer, which is minus 0.2 divided by 1 million. Okay, this is how you calculate your slope. So given that we already know our H, which is our hurdle rate of 25%, A, which is 0.55 as told in the previous example, and B is minus 0.2 divided by 1 million, calculate the optimal investment level. Now, as we all know that our investment level or optimal investment level is denoted as H minus A divided by 2B. So that will be 0.25 minus 0.55 divided by 2, okay, I'm going to put a bracket in there, times B. 0.2 divided by 1 million. Now this will actually give me 0. Okay, so this will give me 750,000. And the second one is rho me. So rho me, or I'll call it rho me star because this is your optimum rho me. It will be your H plus A divided by 2, which is 0.25 plus 0.55 divided by 2. This will give me 40%. And your R star, which is your return star, you can do two ways. One of the ways you can do is calculate your investment level times your ROMI. So investment star and ROMI star. Investment star is 750K times ROMI is 40%, and your optimal return rate, it will be 300K. Now, how do I actually get these formulas? These formulas can be calculated, or actually not calculated. This formula is actually given for you right here. And I'm just using it for my convenience. It says that at the hurdle rate of 25%, right? So you can see here at the hurdle rate of 25%, my ROMI is equals to 25% as well. And this will give me my ROMI of 40% as told in the previous example. And this will give me my marketing investment, I star, which is 750, which is the same as what we calculated, and also my return, or R star, of 300,000. So the scalability example illustrates the benefit of making optimal investment. So you need to make an optimal investment such that you maximize your return. At the same time, you don't spend too much money on one of the particular sector, and you'll be very optimal. So optimal in the way that you are very efficient. So if we invested all 1.5 million, we would generate a return of 375K. How do we actually know this? It was told in here. You will generate 375K from actually investing 1.5 million. That's what it told here. But when we invest 750K into the campaign, which is our optimal investment, then with the hurdle rate, the same hurdle rate, my return will be at least, so 300K plus 0.25 times 1.5 million minus 750K. So this will give me 487.5K. So which means that you have an additional 112.5K or more to the total contribution. Now, why is it actually we have to take the hurdle rate of this minus that? Because that is basically just the hurdle rate of the difference between our two investments. So the managerial implication for this particular example is that your investment decision for marketing are best made incrementally. The reason why is it incrementally is because we can actually find out our optimal solution. Assessment of each incremental investment should be independent of prior decision. So if you remember, there's an example just now of there are two stages, and when the first stage, so stage 1 is completed and you want to build your stage 2, then your decision should be just solely dependent on stage 2, regardless your stage 1's cost. Because the fact that stage 1 has been completed, it is assumed as like a sunk cost, whereby it's already there. If you don't use it, or if you use it, you still have to pay, or you have already incurred the expenses. Marketing should seek optimal investment level because this will give you additional profit, right? Because as you become more optimum, then obviously you will get more money. And ROMI methodology can be used by marketer to counter propose your budget cuts. So if you have a budget cut in your department, then you can just say that, okay, you see that my ROMI is actually more than our hurdle rate, hence we should actually increase our investment level. So it gives you a more concrete directions. So we have touched on ROMI, incremental ROMI, optimal investment theory, and profitability comparison. And that's pretty much it for lecture 12, which is our final lectures of the day. Thank you very much for listening to this presentation. If you have any question, feel free to email me. If not, I'll see you in the next video when we talk about the final exams. See ya.